Right, welcome back. MECH2320, going through chapter 29. Alright, talking about single phase motors. So these are AC motors. Alright, so we're going to go through discussing single phase motors, what split phase motors are, and different starting methods for split phase motors. Or how to reverse the direction of a split phase motor, and then if we have dual voltage operation. Alright, so remember, single phase motor. Okay, this is what we have going on here. So we're doing what? We're rotating that frequency or that phase around in the stator, okay? And we're inducing it on here, okay? We've done that, plenty of that in the mechanical class and everything, all right? So main characteristics, all right? Most motor, in the industry are three-phase motors, but there are purposes where we have single-phase motors. Alright, and the majority of the single-phase motors operate on 120 or 240 volts, and they're for small horsepower motors, okay? You're not going to have like a 30 horsepower motor running off 120 volts or anything like that, okay? They're mostly intended to be, started across the line or directly, wired up to power, alright? And then if we talk about split-phase motors, we're going to talk about how those break down, right? Where we actually take, like a 240 and split it into two separate phases, so that we put the phases 90 degrees out of sync with each other, so that it simulates kind of a rotating magnetic field. All right, so different types of starts. We have resistance start, induction run. All right, we have capacitor start, induction run, and capacitor start, capacitor run. So we're going to kind of talk about what each one of those means. So in general, right, the resistance start induction run and the capacitor start induction run motors, they need to disconnect the starter winding when the motor reaches about 75% of its rated speed. With the capacitor start induction run motor, all right, there's a capacitor that's placed in series with the starter winding. The purpose of that is to increase the starting torque of the motor. That starting torque is increased with that capacitor because it creates a greater phase shift between the run windings and the start windings. So as we get a greater phase shift between those, we're going to get more torque or greater torque. If we're going to talk about the resistance windings the starter windings for the induction run and the capacitor start induction run motors, okay, those are only designed to have the power for a very short amount of time. If those aren't disconnected in time, those will ruin the windings. And with the capacitor start, capacitor run motor, okay, those are designed so that the starter windings are not disconnected from the circuit; those stay in, okay. And those operate to a, similar to a two-phase type motor that we're going to talk about here in a minute. And please don't get me started on like two-phase. It's not really two-phase. Two-phase doesn't exist. The correct terminology is split phase. We have single phase, and we have three-phase, and we have split phase, okay? And we center tap a transformer. So, ideally, right, if we have 240 volts and we center tap it, we can create two 120 phases, okay, off of a single phase. And we can use the capacitor to set the phase difference between them. All right, so let's take a look at just kind of the guts of a single phase motor here. All right, and I'm not a single phase, a split phase motor. We just talked about single phase. All right, so split phase motor, where we're using two separate phases, okay, and how do we set those 90 degrees apart? Take a look at where the windings are. All right, they're perpendicular from one another. So if we look where phase A is, or phase 1A and phase 2A are, all right, you can see that based on inside the motor how those are separated, that's how we can create, we're simulating a rotating magnetic field because of the split phase. Okay, so we might take phase A, phase B, all right, of our split phase. So like I just said, when we took like 240, so this is like what your dryer does at your house. So I got a dryer picture there, right? At your house you use 240, okay, that's normally a single phase, but you're taking you're splitting that and creating two 120s. And when we wind the motor for it, all right, they're set 90 degrees out of phase with one another so that it creates or simulates a rotating magnetic field as it goes through there. So that's how that works. So you're going to see a lot of these in your dryers and in your HVAC stuff at your house, or actually just your air conditioning unit for the most part. All right, but we can take a look at it. You know, structurally it's the same kind of thing. We have a stator and we have a rotor, same kind of concept. All right, now if we have split phase motors, okay, they use what they have is called a centrifugal switch to start up. All right, so it uses centrifugal force. Remember, that's force that's rotating. So we use a centrifugal switch. Okay, that's when it's connected to the rotor of the shaft, and we're using it as for startup. Okay, so what will happen then, as it gets to spin and gets to its operating speed, the counterweights overcome the springs and they disconnect it from the starter. All right, so that's what the centrifugal switch is, and that's how we disconnect by the rotation of the motor using centrifugal force. Okay, if we have a split phase that has a permanent capacitor, all right, we use the capacitor, and we have a starting capacitor, and then we have a running capacitor. Okay, remember, capacitor just stores a charge as we go through there. But centrifugal switch, okay, we can see how that works and how that's wired up. We have the run winding and the start winding in parallel with one another. Okay, and we need both of those right to start, but then the centrifugal switch opens up when the motor gets to the correct speed there and disconnects the start winding from the run winding. Same if we look at the capacitor in the bottom right hand corner. All right, we have a capacitor start and a centrifugal switch there. All right, so we can use those to start up. The centrifugal switch will still disconnect, all right, as the motor reaches the correct speed, and we don't need the starter windings. Okay, so capacitor start or capacitor start run, or let's say this correctly here, capacitor start, or you have capacitor start, capacitor run. That's really what that means. Okay, so why do we use a capacitor start? So it's high starting torque. That's the important part. And then we disconnect the windings at 75% of the speed. And when I say disconnect, we're disconnecting the start portion of the windings, the start piece. Okay. Now, if we use a capacitor start, capacitor run, we don't disconnect the windings. Okay, we consider it a true two-phase, and I don't like that term, but it comes up to be like a split phase. All right, those are used in AC units and ceiling fans. And then we have a hot wire starting relay. Okay, those are same kind of concept here, but they're for airtight sealed motors, or hermetically type motors. So those are inside of refrigeration, air conditioning units, submerged pumps, okay, sump pumps, things like that. Things that you can't get access to. So that's where we use the hot wire starting relay. It's only in enclosed environments like that. Okay, and you can take a look at how the current relay hits on there. So we have the starter contacts, and then that relay coil, right, that just creates a magnetic field. So we use a thermistor in there, and when that thermistor closes, right, based on temperature, we have all of those working together, and we have the starting capacitor. Okay, we can also use a solid state. Remember, anytime we're talking solid state, we're talking our little IC chips in our electrical board. Essentially, there's a small electronics board that's in there, so we can use solid state starting on the relay circuit. Okay, and then we can use a potential. So remember, potential is like a charge, or the ability to do work, essentially. Okay, but we can use a potential, and how do we create that potential inside there? We're using capacitors. So the capacitors store that charge, and then we use them. Now, remember that this is the capacitor start, capacitor run over here. So we don't disconnect those two. We'll use them in parallel. So you got capacitor run, capacitor start. Okay, so let's talk about dual voltage motors. Okay, so we have some split phase motors that operate off 120 or 240 volts. So we use two separate sets of windings. Okay, we've talked about this a little bit in the previous part of the lecture. Okay, but sometimes there's only one start winding, so you got to just kind of pay attention, and you'll look at the nameplate and see what's on there. Okay, so that you can actually, understand what type of motor that is, what you're looking at. And even if we look at the nameplate that's here, right, you can see that there's two capacitors in there. There's CR1, which is 30 microfarad, and there's CR2, which is 30 microfarad. Okay, so that we can see that that's in there, and we know that it's a 240 volt AC motor. Okay, so how do we also know? There is no three-phase, so we know that this is single phase. Now, this motor can operate on two voltages, 120 or 240. Okay, it'll be able to operate at either one of those. And we can see the RPMs for the low voltage, and we can see the RPMs for the high voltage. So it's 1350 for the 120, and it's 1650 for the 240. All right. So hopefully we can kind of understand, how that's going. So, we'll have 6 leads inside there, and we went through another lecture where you can see how to tie up the leads and the terminals, how everything goes together. That's usually on the motor plate. Okay. Now, how do we reverse the direction of rotation? So what we can do is we can change the run or the start windings with each other. Change the run or the start windings. And you guys did this in a lab in the mechanical class when you did rotating electrical machines. Okay. Something a little bit different about the single phase motors is we determine the direction of the motor by standing behind it in this scenario. Remember when we talked about DC motors, right? DC motors, we face the commutator piece, and that tells us the directions. With these single phase motors, we're going to face the rear of the motor, all right? And that'll give us the direction of rotation that we're talking about. Okay, so some of these we already talked about multi-speed motors or single phase motors, and we're able to operate them at more than one speed. So we can operate them at synchronous speed. Okay, so that's where we generate that rotating magnetic field. All right, because we use a split phase to go through there to do that, and that's also determined by the number of stator poles that we have and the frequency of the applied voltage. Okay, because remember we have to get those 90 degrees. So if we have a consequential pole motor, we're going to change the speed by changing the number of stator poles. All right, so it just depends on how many poles that we have sitting in there, and then we can also change the direction of current in the run winding. So that's how we can change speed there. So if we take a look here, right, the direction of current flow through each winding is the same because it's in series. Okay, now if we have them as such with a center tap, okay, this is going to change a little bit because we actually form two different magnetic poles because of where the tap is on these. Okay, so that's something that we got to make sure that we pay attention to if we're working on one of these kind of motors. Okay. Lastly, what does this come down to? If we have a multi-speed fan, and if we take a look at how we change the speed, because we go over, we have a fan, we have low, medium, and high speed. Well, how is that affected? So what happens when we connect everything? Okay, so why is it low speed? Well, because if you look through, we got to go through all 3 of those in series to connect the circuit from L1 to L2. So it's got to go through more, so we won't have the resistance, the reactance I should say in this case, because those are coils, will be greater. So that's why it's low speed. If we toggle the selector switch to medium, all right, then it's only going to go through 2 inductors or 2 coils. Okay, so the reactance will be less. All right, or the reactance, remember reactance and resistance are somewhat interchangeable. We refer to reactance with inductors and with resistors, or I'm not with resistors, with inductors and with capacitors. Okay, and then if we switch to high, okay, the path only goes through the main run winding. Okay, so the reactance is even less. All right, so less resistance. All right, so that's why it would be the highest speed. We would have the most current. Okay, so it just depends. This is how your fan, the windings that you're interfacing with inside of your actual fan. So that's how multi-speed fans work. All right, well that's it for this lecture. All right, we're wrapping up single phase motors, and hopefully we kind of have an understanding there of single phase versus split phase versus capacitor start versus capacitor start, capacitor run type motors, and how we interface with those, and what centrifugal switch is and those kind of things. So, as usual, guys, email me if you got a question. Else, have a great day. Talk to you soon.